Okay, we're looking at quadrilaterals, and we have this handy dandy flip book to help with quadrilaterals. First of all, what is a quadrilateral? What? Four-sided figure, right? They don't have to necessarily be equal. It just describes a polygon with four sides. So name a quadrilateral that you know of. Just name one. Huh? Square. Name another. Rectangle. Those are probably the two that everyone knows. I'm going to teach you two new ones. Parallelogram and rhombus. If y'all would, please make sure to take your AirPods out. My board. Turn on. Okay, we said this is page 42. This is page 42 in your notebook. We will glue it to notebook paper so it has a way to stay in your notebook. We are going to open up the first flap and look at parallelograms. The shape parallelogram encompasses what we're going to talk about later this week, okay? Parallelogram is the umbrella term for some other types of shapes that we're going to talk about. Today, though, we're just going to focus on parallelograms. Notice how your flip book is organized. The top of the flap, as you browse through, you will browse through your entire flip book right now. The flap that you fold up is the new shape, and it'll show you the properties. And then the part that is laying flat on your desk that does not fold is where there's example problems, okay? So that's how the flip book is organized. So we're going to fill in the properties up here at the top, and then we're going to do the example problems, and then we have a practice worksheet. So parallelograms has a lot of properties. Let me see if I can zoom in further out. Ooh. Oh, that was too much. Okay, that's not bad. And yeah, y'all can see that. All right. So the first property, this makes sense why it's called a parallelogram. Opposite sides are parallel. Opposite sides are parallel. Hence the reason it's called a parallelogram. So if you ever forget the property that opposite sides are parallel of a parallelogram, it means you didn't make the connection with the word itself. Remember the notation on a shape when something's parallel. There's two types of notations. I'm going to show them both to you because you're going to see both of them. One of them is it's these little tiny triangles. They kind of look like like the end of a bow and arrow, these little tiny triangles. That means parallel. Here is another type of symbol to mean parallel. It's when it's almost a triangle, but they don't quite fill it in. So it looks like a feather at the end of a bow and arrow. And whichever sides have that symbol, that means they're parallel to each other, okay? So there's two types of symbols there for parallel. You can come over here and make a note to yourself if you want. You can do your, two little triangles like that, and you can do your two arrows to show that those are the symbols. Now, here's what you need to keep in the back of your mind. Do y'all remember, because it wasn't that long ago, do you remember when we learned about parallel lines, cut by a transversal, and then you have all these angles that are congruent to each other. Do you remember this? I think it was about 2 weeks ago. Do y'all remember that? That is going to come into play because we have parallel lines, and then this diagonal is deemed a transversal. And then if you turn your head sideways, you have another set of parallel lines, and then here's a transversal. So that's those angles that we talked about a couple weeks ago are going to come into play. The most popular one that you're going to see is alternate interior angles. So to give you a heads up, like there's, imagine that's parallel. Let's go with it. And then we have a transversal. Well, the alternate interior are the ones that are on opposite sides of the transversal but inside the parallel lines. Remember that? Alternate interior angles are going to come up. So that's just a little preview of what's to come. Okay, the next two are straightforward. Opposite sides are congruent, meaning equal. So this side here, I'm going to do 2 tick marks, is congruent to this side here. This side here is congruent to this side here. Opposite angles are also congruent. Now, this one's a little harder to demonstrate in our picture. So it might be helpful if you can change to like a colored pen so it sticks out. Here's what I mean by that. Let me change to blue so you can see what I'm talking about. Maybe I can't get the thing to pull up an additional color. My board must think it's already fall break. All right, let's try that again. There we go. I'm going to change to blue. And the reason I'm going to change to blue is because the angle that I need to mark is stretching from, don't mark this yet like this, but it's stretching from here all the way to here. And since that diagonal cuts right through that, it makes it hard for you to understand. I'm talking about the whole corner. I'm not talking about this or this. I'm talking about the entire thing together. Does that make sense? So I'm going to make a mark in a different color, and I think it's going to help you to see the big picture here. I'm also going to name the corner. I'm going to mark this really big and exaggerated with an arc and call it A. And then I'm going to come over here and mark this really big and exaggerated and call it C. So opposite angles are congruent. So for example, angle A is congruent to angle C. Now that's not the only pair of opposite angles, but this is going to get crowded, so we don't have room to write every single thing. But to give you an idea, because A and C are on opposite corners, diagonally opposite of each other, they have the same measure. The same is also true if we come over here and we call this B and this D. Angle B is congruent to angle D. Okay, so that's also true. Now, consecutive angles. This means angles that are on the same edge. So for instance, angle A, let's go ahead and label this angle B, this is C, and we'll go ahead and label this D. And when I say angle A, I'm talking about the whole corner. Technically, I need to call it angle DAB or BAD, but since I'm trying to teach you this content, I want you to just focus on the one letter, and I am talking about the entire corner angle, okay? Notice this says consecutive angles are blank. Supplementary. Do you remember what that means? They add to equal what? 180. They add to equal 180. All right, so now I'm going to go back to that colored pen that we were working with a second ago. So if they add to equal 180, then angle A, now here's what it means by consecutive. It means on the same edge of the shape. Angle A is on the same edge as angle D. Do you see that? Looking at the picture. Angle A is on the same edge as angle B as well. Do you see that? So those are called consecutive. You have A and D consecutive. You have A and B consecutive. You have B and C are consecutive. C and D are consecutive. It's the two angles. If you were tracing the shape, it's the two angles that you would come to back, okay? Now, this angle over here is acute. I'm going to make 2 marks. I'm going to make 2 marks on that one. And then I'm going to come over here to this one, and I'm going to do 2 marks as well. I am extending beyond the shape because I want you to understand it's the entire corner. Okay? It's the whole corner. It's not just a little piece. It's the whole corner. All right. And then I'm going to come right here in this little gap and I'm going to make a note. For example, angle A plus angle B equals 180 degrees because they are consecutive. We have two more. One more really, but then we're going to make a little, keep this in mind, note. The last one says diagonals blank each other. Well, they definitely intersect each other, right? But that's not as interesting. We need a math term in here. So we're going to make a note that they bisect each other because when we start studying the parallelograms, we're going to find out that the diagonals cut each other in half every time. Okay? Remember, bisect means cut into 2 equal parts. So if I say something has been bisected, that's huge. I've just told you that there's 2 equal parts in there. Okay? A lot of people overlook the word bisect and they don't see the math equation in it. The math equation with bisect would mean something equals something, right? That's one of the math equations. That's the one used most often. Another type of math equation, if I said something is bisected, would be if you take half of it and double it, you get the whole thing, right? If something's cut in half. So if you double half of it, you get the whole thing. All right, we have one property left, and then we're just going to practice. It's not necessarily a property. It's let me help you out and remind you of what to look for so that you don't get stuck. When you have diagonals drawn, we're going to try to add this. If you have any space right here, this is where we're going to add this little sentence, okay? When diagonals, and we're not even writing in the complete sentence because I know you don't have a lot of room. alternate interior angles. Anytime the diagonals are drawn, look for alternate interior angles to possibly come up in your problem. And remember, they are congruent to each other. So let's make a little note, congruent. They are congruent to each other. Okay, so those properties are what we're going to use to answer these questions. You'll notice we didn't make any marks on our diagonals in our picture because the picture's already getting really busy. To help you understand what kind of marks would exist here, you don't have to write these down. I can change colors, which helps, but if you just want to look, so like this diagonal BD has been cut in half. And then this diagonal AC has also been cut in half. But see, it starts to get really busy if we put all of that on there. But those are extra marks that when we start solving these problems might help. Now, here's in order for me to be able to show you the problem, I have to slide the thing up. Let me see. All right, so let's try that. There we go. Okay, so we're looking right here. If ABCD is a parallelogram, find each missing measure. All right, stay with me, y'all. Stay with me. So look, notice we have several questions here. What do you notice is the difference between how these ABC are written and how DEF are written? What's different about them? ABC questions have only 2 letters. DEF has 3 letters. There's another big difference. There's an angle symbol in DEF. Notice there's no angle symbol in ABC. Okay, so this is your indication that this is talking about sides or segments, sides or diagonals, either one. This is either sides or diagonals, and then this is angles. So that's the first big difference between the two. So now you need to start training yourself to know that if I'm just saying 2 letters, I'm referring to a segment, right? A linear segment. If I have an M angle measure and 3 letters, I'm talking about an angle. Okay, so let's look at the picture. There's a lot of information here. Y'all with me? Notice it says side BC measures 15. Notice it says CD measures 8.4. Notice diagonal part AE measures 10. Diagonal part DE measures 7. Then we have 33 degrees here. We have 43 degrees here. Then we have 23 degrees here. Do you see all of that? Notice I did different congruent or different arcs because they're not the same measure. Okay? All right, so now let's solve. It is a parallelogram. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals are cutting each other in half. Okay, so this says find AB. AB, I'll use my highlighter to draw your attention to it. AB is right here. Where should I look to see if I can immediately state the length of AB? Where should I look? Yeah, go to the other side of the shape. Notice that CD measures what? Yeah, it measures the same thing. because it says opposite sides are congruent. So AB is 8.4. Now it says find A to C. Well, what part of the shape is that? Is it a side or a diagonal? It's a diagonal. Go to your properties. What do you know about diagonals? What does the property say about diagonals? They bisect each other. Bisect means cut in half. Do I know anything about that diagonal at all? Do I know anything about it? I know that this little segment right here is 10. So what would the other be? Very good. So what's the whole thing? There you go. So this would be 10 over here as well. Now it says to find BE. Okay, ask yourself, am I talking about a side or a diagonal? It is a diagonal. So BE would be what? 7. Because the other side of it is 7. So this would be 7. With parallelograms, if I had to rank, like what's the easiest part, what's the more challenging part, I would say the sides and the diagonals are the easiest part. Opposite sides are equal, diagonals are cut in half. That should be the easiest part. Now, the angles is where you have to stop and think. Okay, you have to remember your properties, and I'm giving them to you right here. So let's look at these angles. Also remember how to read angles. You have to read it with 3 letters, and you go back to the middle letter, and it's the corner of that, what you just traced. So this says find the measure of angle BAD. BAD. That would be the entire corner right here, correct? Let me put that back. All right. So do we have any clue at all about what that angle measures? Do we happen to know it to begin with? No, it's not labeled. Do we happen to know the one opposite of it completely? Completely. Not entirely, right? But we do know, what does it say right here? It says opposite angles are what? Congruent. We know a piece of the opposite angle. This is a stretch. I hope you're paying attention. We know that this piece right here is 43. Now, coming to the angle I'm trying to find, I know this piece is 23. What did I say to look for if the diagonals are drawn? And that's exactly what you're going to use right here, which is why angles are a little more challenging because people forget to look for the alternate interior angles. Let me show you where they are. I'm going to use red so it draws your attention to it. Do you notice how this side and this side are parallel? You see that? And then this would be a transversal. You with me? Follow along. If this is 43 here, cross, and come down here, what's this? 43. Do you see that? All right, so let me take that off. So this would be 43 degrees. Now, do I have enough to say the whole corner? What's the whole corner? From here to here.
66.
66. And how'd you get it? Yes. So So I'm going to draw, this is also what's helpful. Now that I've just found that, I'm going to draw that really exaggerated arc, extending outside of the shape so that I remember that this is the entire corner. And I'm going to write 66 degrees. And that's my way of saying, okay, Ashley, when you deal with this shape, this corner is 66 degrees, the whole corner. Because we may need it for a future question. Next says, find the measure of angle ABC. A to D to C. So again, this is the entire corner. Well, this is why writing that 66 is going to help me. Let's look at our properties. First, we know opposite angles are congruent. Well, if I come opposite of this angle that I'm trying to find, do I know the whole angle up here? No. So that's not going to help me. What's another angle property? Consecutive angles are supplementary. That means angles on the same edge of the shape. Notice that this angle over here we said is what? The whole corner, right? So if that's 66 and this is on the same edge of the shape, do I have enough info to find it? Yes. It would be what? Yes. And if you need to make a note, you would say, we'll say 114, and then you could make a note, 180 minus 66 is how we got it. And then I'm going to come over here and draw two exaggerated arcs, two of them. And I'm going to make a note that it's 114 degrees. Normally, we will not have questions that involve the exact same shape like this. Normally, it's one question per shape, maybe, or two questions per shape, and then you move on to the next shape. This gets complicated because of how many pieces of information are all on the same picture. So they're not always like this, okay? This was just this flip book is a nice way to try to show you a little bit of each type of question, but obviously with the flip book can't be 30 pages long, so we just put it on the same shape. All right, we have one left. It says angle ABD. ABD. Got to be careful there. And it's going to be the elbow. So it's talking about right there. Well, what do I know that's right next to it? What angle do I know that's right next to it? 33 is right next to it, right? Now, does that 33 actually apply in here, though? No, it's over here. It's a puzzle, and your clue is either next to it or opposite of it. So my clue is either over here next to it or coming opposite. The one I would start with is opposite because opposite angles are congruent. So I would start with that one first because then it's less work. What's opposite of angle B? Angle D. And what did we say angle D measures? The whole corner D. 114. So if this whole corner measures 114 degrees, and this little piece here measures, that I don't need, measures what? 33. How would I find this? Very good. And you should get 81. So make a note, you got that by doing 114 minus 33. All right, let's do example 2 and then we'll go to the practice. It says PQRS is a parallelogram. Find the measure of angle PSR. So I'm going to take my highlighter. They want the measure of angle P to S to R. So this is the goal. It helps to put question marks on the goal. That's the goal. Right? Well, what other angle in that shape could I find and that would answer my question? What? Yes. Okay, so if I'm trying to find angle, and we can actually call this by a single letter because there's no diagonals drawn. If I'm trying to find angle S, if I found angle Q, and I actually have a chance to do that because there's something there, then I would have the answer to angle S. Angle Q is congruent to angle S because they're opposite. So now I can focus my attention on, okay, let's find angle Q. Well, look at your clues that you have in front of you. First of all, are we dealing with segments or angles? Segments or angles? Yes. Your clue that it's an angle is the degree symbol right here and here. Okay? Look for that. Those clues are going to help you to know what properties to use. So if we're dealing with angles, we only need to look at the properties with angles, right? We don't need to worry about the properties that talk about sides or diagonals because there's no diagonals drawn. We don't know the sides. Look at your angles. You have this angle Q, you have angle P. You only have two angle properties. One deals with opposite, one deals with consecutive. Which one would help me here? The angles that we have information about, Q and P, ask yourself, are they opposite of each other on the shape, or are they consecutive? Y'all, please help me out. The question is, angle Q and angle P are positioned on the shape. Are they opposite or are they consecutive? They're consecutive because they're on the same edge of the shape. Opposite would be angle Q and S. They're opposite. Angle P and R, they're opposite. So let's make a note. Angle Q, angle P, we don't have a lot of room. We're just going to make an abbreviation. They're consecutive. What's the property for consecutive angles? What's it say to do? All right, what's it say that they add to equal 180? So angle Q plus angle P adds to equal 180. And there's your equation. Something plus something equals 180. And you would solve for x. So we've got 7x minus 13 plus 4x minus 5 equals 180. Add the 18 over. I'm running out of room. Divide by 11. Did you get 18? Now, knowing that x is 18, does that actually answer the question? No, that just tells me what x is. The question was, what's the measure of angle S? And we said we don't really have to find angle S. We can find angle Q. Now I know what x is. What do I do? Plug it in. So angle S is going to be the same expression as angle Q because we said they're congruent. So I'm going to plug 18 in and then type it in my calculator to get the answer. Is it 113? Yeah. Alright, so the paper that I just passed to you is page 43, and you will notice that it has 14 questions total. And like I said, this time each question only has the info on it for like one problem. You don't have a problem like this one right here where there is all this information and it gets confusing. They do start out with level of difficulty with just numbers, and then when you go to the back, you will notice now we no longer have just numbers. Now we have polynomial expressions, which was what this example was comparing it to. The first one was just numbers. The second one involved polynomial expressions that you had to like set up an equation and solve. So the front is numbers. The back, you're going to have to set up some type of equation, okay? So let's look at it. Alright, this is page 43. You don't have to fill in the top part right here, but if you want to, it would be the stuff that's in your flip book that we put at the top. But I would just use your flip book to help you. So we have properties of parallelograms. Let's draw a parallelogram right here. So to draw a parallelogram, imagine a rectangle being pushed, being slanted. Imagine a rectangle being slanted. And the main properties of a parallelogram, opposite sides are parallel. I'm going to do the arrows since I don't have a lot of room. Opposite sides are parallel, so that means parallel. Opposite sides are equal, so these straight tick marks mean equal. We're not going to try and draw info on the diagonals because then it's going to get crowded and confusing. But let's label the corners, and let's remind ourselves that opposite angles are congruent. So like angle A is congruent to angle C, for example. Angle B is congruent to angle D. Let's also remember that consecutive angles are supplementary. So, for example, angle A plus angle B equals 180. So those are the two properties with angles. The other two boxes you can fill in with opposite sides are parallel, opposite sides are congruent. 1. Each quadrilateral below is a parallelogram. Find the missing measures. Remember the difference between a segment versus an angle. Segments have 2 letters. Angles have the angle symbol in front of them. Okay, looking at our picture. This is a very basic parallelogram. Before I even answer these questions, my mind immediately wants to fill in the stuff I should know. Like if this is 15 here, then what's this? 15. If this is 8, then what's this? 8. You fill it in kind of like you would with a rectangle, because it is a rectangle essentially pushed slanted, right? If you keep that in mind, it'll help you remember. And then remember, opposite angles are congruent. So if this is 68, what's this? 68. And then now I can go to my questions. It says, what's the length of AD? That would be the edge, the side. It's 8. What's the length of DC? 15. What's the measure of angle A? I don't have that one, right? But do I have enough info? If you know at least one angle in the parallelogram, you can find all 4. Because opposites are equal and consecutives add to 180. So if the consecutive angle is 68, angle A would be 112. And how'd you get that? You subtracted it from 180. We said angle B measures what? 68. And angle C measures 112. Your homework assignment, your practice assignment is the parallelograms. Yeah, I want you to get the front done. I want the front done, okay? You with me? Just the front. You can go to the back if you want, but the front's what I'm looking